Hello, welcome to this class. In today's class, we will start with numericals on ideal and real gases. Particularly, since we have discussed the equations of ideal gas, we will solve few numericals on ideal gas. So, let us start. An automobile tire is filled with a gauge pressure of 210 kilopascal. Remember, the equation which we wrote, PV is equal to MRT, the pressure and temperature has to be absolute pressure and absolute temperature. So, the value here given is gauge pressure, that is 210 kilopascal. And we are familiar with absolute pressure is given by gauge pressure plus atmospheric pressure. Okay. So, gauge pressure is 210 kilopascal and we know atmospheric pressure is 101.325 kilopascal, and this is a known value, atmospheric pressure. So, we will get 311.325 kilopascal. Okay. So, P absolute is equal to 311.325 kilopascal. But we want to represent it in Newton per meter square. So, 311.325 into 10 power 3 Newton per meter square. And temperature is 25 degrees Celsius. Temperature is 25 and we want it in Kelvin. So, 25 plus 273 Kelvin. So, it is 298 Kelvin. Okay. After driving, we are pretty much clear. After driving, temperature of tire increases, right? So, after driving, temperature increases by 1 degree Celsius for every kilometer. So, delta T we can say is 1 degree Celsius for every kilometer. Find the pressure after 25 kilometer. Delta T is 1 degree Celsius for every kilometer. So, total temperature increase will be 1 degree Celsius per every kilometer multiplied by the distance covered, that is 25 kilometers. So, kilometer gets cancelled out. So, you will have 25 degree Celsius increase, which means T2 is initial temperature plus delta T. So, that is 25 initial temperature is 25 degrees Celsius plus delta T is 25 degrees Celsius. So, total temperature after driving 25 kilometer will be 50 degrees Celsius. Therefore, T2 in terms of Kelvin will be 50 plus 273. So, that will give us 323 Kelvin. Okay. Now, find the pressure. So, we are interested in the pressure P2. Now, how do we find P2? We know the relation PV is equal to MRT for a closed system. So, PV is equal to MRT is used for a closed system. And we know that this can be PV by T is equal to M into R. These two are constant. We have proved from combined gas laws, Boyle's law and Charles law, that PV by T will be equal to constant. And we are talking about a tire. So, we will have to assume the volume is constant. If it is not given, but we will have to assume that volume is constant, otherwise we cannot solve this equation. Assume that volume is constant. We'll have P by T, volume goes to the right side, so P by T will be equal to constant, which means P1 by T1 is equal to P1 by T1 is equal to P2 by T2. So, P1 is known absolute pressure 311.325 325 into 10 power 3. 325 into 10 power 3. T1 is 298 and P2 is what we are interested in and T2 is 323 Kelvin. So, the only unknown will be P2 and remember the value of P2 will be in absolute pressure. We can solve this equation 311.325 into 10 power 3. Now, as usual, we'll use alpha equals. This unknown will always keep it alpha x divided by 323. Then go for shift, solve for x is equal to 0. So, equals. The answer is 337.44 into 10 power 3 into 10 power 3 Newton per meter square. 337.44 into 10 power 3 Newton per meter square. Remember, this is the absolute pressure. If you want gauge pressure, the same has to be subtracted. So, gauge pressure, we know this equation, right? P absolute is equal to P gauge plus P atmospheric. Now, if you have absolute pressure and if you want gauge pressure will be equal to absolute minus atmospheric pressure. So, absolute is here P2, absolute minus atmospheric pressure, which is 337.44 kilopascal minus 101.325 kilopascal. 337.44 minus 101.325. 236.115. 236.115 kilopascals. So, I have written it in kilopascals only. So, the 337.44 kilopascal. We will solve few more problems in the next class. Thank you.